Welcome to this demonstration on remote VCN peering. Let's get started. Here we are considering two regions. The first region is Phoenix. The second region is Mumbai. So we have a VCN created in Phoenix and another VCN created in Mumbai. So inside the public subnet, there is an instance running on both the sides. So what we'll do is we'll try to establish a communication between these instances privately. So let's get started. What we would typically do here is we will create DRG on both the sides. Then we'll create a remote peering connection and then establish a connection between the two. Apart from that, we will also configure the route tables and security lists. So let me take you to the OCI console. The first two tabs will show you the resources in Phoenix, and the next two tabs will show you the resources that I have configured in Mumbai region. So to start with, in Phoenix, you see there is a VCN, VCN-A. This is the CIDR 10.0.0.0/16. In Mumbai region, VCN-B is the name of the virtual cloud network, and this is the CIDR 192.168.0.0/16. What I have also done is that in Phoenix, there is an instance running inside the public subnet in my VCN, instance A. This is the public IP, this is the private IP. And in Mumbai, I have created an instance B that is running inside VCN-B, and these are the IP addresses. So let me copy the private IP address of the instance B running in Mumbai, and I'm connected to instance A, done an SSH to instance A. So I'll try to ping this particular IP. And you'll see that it's not successful. So let's first configure remote peering. So how do we do that? I'm in Phoenix. I'll go to this particular VCN and just see that as of now, I have a route table that has a route out to internet through internet gateway. So as of now, there is no dynamic routing gateway. So the first thing that I will do is I'll go to networking under customer connectivity, click on dynamic routing gateway. I'll create a dynamic routing gateway and I will name it DRG Phoenix. Click on create dynamic routing gateway. Similarly, I will go to Mumbai and create a dynamic routing gateway there as well. So I will call it DRG Mumbai. Click on create dynamic routing gateway. So you see that the dynamic routing gateway in Phoenix is now available. Similarly, the dynamic routing gateway in Mumbai is currently provisioning and it is going to be available. So now I'll return back to Phoenix. I'll create a virtual cloud network attachment. So I'll select VCN-A, click on create VCN attachment. Similarly, I'll go back to Mumbai and create virtual cloud network attachment VCN-B. So now I have created the dynamic routing gateway on both the VCNs. So now it's the time to configure remote peering connection. So I'll return back to Phoenix. I'll wait for this lifecycle state to become attached. Okay, so now it is attached. So I'll click on remote peering connection attachments. I'll click on create remote peering connection. I will give it a name. Demo RPC. Click create remote peering connection. Okay, so it is currently getting created. Similarly, I will go back to Mumbai click on remote peering connection attachments, create. Okay, so if I return back to Phoenix, I see that the lifecycle state is now attached for my remote peering connection attachment. And this is the remote peering connection. And the peering status says new or not paired. We'll go back to Mumbai and I will wait for this lifecycle state to be attached. So this is the remote peering connection demo RPC2. So I'll click on demo RPC2 and I'll copy the OSIT for demo RPC2. I will return back to Phoenix. So here I will click on demo RPC and here you see there is an option to establish the connection. So I'll click on that option. Remember, I am inside Phoenix. So the region that I will select is Mumbai, AP Mumbai 1. And this is the remote peering connection OSIT, which we have already copied. I'll just put it here, click on establish connection. So you see that the peer status is now pending. The peer region is Mumbai. Okay, so now you see that the peer status is paired. If I return back to Mumbai, just do a refresh, I will see that the peer status is paired and the peer region is US Phoenix 1. So that means my remote peering connection is now created. So the peering is now done. If I return back to the instance A in Phoenix and try to ping the instance in Mumbai, it will still not be successful because we are yet to create routing rules and security list. So let's very quickly do that. Let me go to networking, virtual cloud networks in Phoenix. I'll go to VCN A, I'll configure the route table, click on default route table, add route rules. The target type is dynamic routing gateway. The destination is 192.168.0.0/16. This is basically the CIDR for VCN B, which is created in Mumbai. Add route rules. Okay, so I will also add the security list. Basically add a rule, add ingress rules. The source CIDR is 192.168.0.0/16 and the IP protocol is ICMP. Click on add ingress rules. So I'm done from the Phoenix side. Now returning back to the Mumbai side, I'll click on networking. I'll go to virtual cloud networks, VCNB, make those two changes. Target type dynamic routing gateway. The destination CIDR is 10.0.0.0/16. Add route rules. Now I will add the security list, add an ingress rule. The CIDR is 10.0.0.0/16. This is the CIDR for my VCN A and the protocol is ICMP. I'll click on add ingress rules. So now if I return back and try to ping my instance in Mumbai using private IP address, I'll see that this works perfectly fine. Now let's do the test from other side as well. So I'm currently inside Mumbai. Let me connect to this particular instance. Okay, so I'll copy the private IP of the instance in Phoenix and I will just try to ping it from the instance in Mumbai. You see, this is working. So this marks the end of this demonstration on remote VCN peering. I hope you found this demonstration useful. Thanks for watching. Welcome to this lesson on Border Gateway Protocol Basics. So let's first try to understand what is a Border Gateway Protocol. So BGP stands for Border Gateway Protocol. And this BGP determines the best network routes. Ultimately, we know that for data transmission to happen on internet, so let's say this is the source and this is the destination. And if the data is flowing from the source to the destination, the data is going to travel through multiple networks. So it can be network 1, it can be network 2, network 3, just to illustrate this. So the data can travel through multiple networks. Now, when the data travels through multiple networks, it's the Border Gateway Protocol which is going to select the best network routes. So what this BGP is going to do is it will look at all the available paths and then going to select the best route. There is also a concept of autonomous system. So you can think of this autonomous system as a smaller network under the control of a single administrative entity. Now this autonomous system is going to have an autonomous system number. And when we have, for example, we have two different autonomous systems, AS1 and AS2, there's also a concept of BGP peer. This is also going to have a BGP peer. So basically, what is a BGP peer? Think of it like a device on the edge or boundary of an autonomous system. And these BGP peers, they are going to exchange the routing information. So this is how the BGP works. So BGP is going to perform the route discovery, and it's also going to perform the path selection. So let's now go to the deck and learn more about BGP. So BGP, as I mentioned, stands for Border Gateway Protocol. So it's the routing protocol for the internet. If I were to give you a layman example, if you are traveling from one place to another place, you typically take the example of maps. So maps is going to show you the optimized traffic route. Similarly, this BGP, it is going to provide you, or it is going to select the best possible route for your traffic. And I mentioned that there is a concept of autonomous system, and each autonomous system is going to have a BGP peer, and those BGP peers, they exchange the routing information with neighboring BGP peers. And autonomous system is nothing but think of it like a collection of connected IP networks. So it's a smaller network which is under a control of a single administrative entity. So BGP is going to look at all the available paths that the data could travel, and then it is going to determine the best route. So what it typically means is if the data is traveling from source to destination, the data is going to travel through multiple networks. And BGP is going to determine the best network routes for data transmission on the internet. So let's look at this example. So here we have around 6 autonomous systems. Let's say the packet wants to be transmitted from AS1 to AS3. Now you see that there are two different ways. So hop 1 is from AS1 to AS2, and then hop 2 is AS2 to AS3. So there are two hops in this path. There is another way to reach to AS3 or autonomous system 3, that is via AS6, AS5, AS4, and then AS3. So in this case, there are 4 hops. Here BGP is going to make a decision. In this scenario, it's pretty straightforward. It will go with the less number of hops. So it is going to select option number 1. So why is BGP important from an OCI standpoint? We know that in OCI, there are two ways in which you can connect to your on-premises network. The first is through site-to-site VPN, and then the second option is using Fast Connect. So if you are using site-to-site VPN, it can use either BGP or static routing, or it can also be a combination of both. But in case of Fast Connect, it always uses Border Gateway Protocol for route advertisements. Therefore, having knowledge on Border Gateway Protocol becomes really critical when you are configuring either site-to-site VPN or Fast Connect virtual circuits. So this marks the end of this lesson on Border Gateway Protocol. Thanks for your time. Hello and welcome to this lesson on Dynamic Routing Gateway, or DRG. Let's get started. So I will do a whiteboarding to help you understand what is this DRG or Dynamic Routing Gateway. This is basically a virtual router. This can have a number of attachments. For example, it can be attached to a virtual cloud network, so VCN attachments. It can also be attached to remote peering connections. It can be attached to IPsec tunnel, which is a part of site-to-site VPN connection. It can also be attached to a virtual circuit, which is a part of Fast Connect. And then you also have something that is known as loopback attachment. So when you would like to forward a traffic from a virtual circuit attachment to an IPsec tunnel attachment within the same DRG, that is what is known as loopback attachment. So we can have different types of attachments when it comes to dynamic routing gateway. Now let's talk about routing. Routing in a dynamic routing gateway. So there are two entities by which we can control routing. The first entity is DRG route tables, and the second entity is DRG route distribution. There are two route tables which are automatically created when you create a dynamic routing gateway. So the first route table is auto-generated DRG route table for RPC, virtual circuit, and IPsec attachments. The second one is auto-generated DRG route table for VCN attachments. So there are two route tables. One is for VCN attachments and the other one is for all other attachments. We also have two types of DRG route distribution. The first one is import route distribution, and the second one is export route distribution. As I mentioned, when you create a DRG, these two route tables are automatically going to be created, and two import route distributions are also created, and one export route distribution is also created. So in the next whiteboarding, we will focus on these import route and export route distributions. So let me first look at import route distribution. I mentioned there are two import route distributions which are auto-generated. So the first one is for all routes, and the second one is for VCN routes. There is just one which is known as default export route distribution for DRG. So two import route distributions get automatically created and one export route distribution gets created when you create a DRG. Let me put the DRG routing table on one side and let me put the import route distribution on the other side. And this is a very important topic. I mentioned there are two route tables whenever I create a DRG. The first route table is for remote peering connection, virtual circuit, and IPsec attachments. And its name is auto-generated DRG route table for RPC, virtual circuit, and IPsec attachments. And the second one is for VCN attachments. Now, what is going to be the import route distribution for this route table? It is going to be, I mentioned there are two, right, which are automatically created. So this is import route distribution for VCN routes. And in this case, it is going to be import route distribution for all routes. So the route table for RPC, virtual circuit, and IPsec attachment is using the import route distribution for VCN routes. And the route table for VCN attachments is using the import route distribution for all routes. And I will give you an example to help you understand. Let's say this is a VCN and this is a remote peering connection. Now let's say this is your dynamic routing gateway. First you attach this VCN, that means it is a VCN attachment, and then it is a remote peering connection attachment. Now if this is a simple setup, what do you think which entries will be there in the first route table and which entries will be there for the second route table? So for the first route table, which is the route table for RPC, virtual circuit, and IPsec attachments, it will import the routes for only VCN. That means in this route table, there will be a dynamic route for VCN. Because the route table for VCN attachments, it is importing the import route distribution for all routes. Therefore, in this particular route table, there will be two routes, one for the VCN and the other one for remote peering connection. So this is how it is going to work. So this concludes the first part of whiteboarding for dynamic routing gateway. In the next part, we will learn more about the dynamic routing gateway. Thanks for watching. Welcome to this lesson on dynamic routing gateway. This is part 2 and we are going to continue the discussion on DRGs. So let's get started. In the previous lesson, we discussed about the DRG route tables, basically which all route tables get created when we create a dynamic routing gateway. And I also talked about the route distributions. We can have different types of attachments to a DRG. For example, virtual cloud network attachments, IPsec attachments, virtual circuit attachments, remote peering connection attachments. We also have a loopback attachments. Now the scenario is we would like to route traffic between the attachments. How to route traffic between attachments? The answer is using route tables and specifically dynamic routing gateway route tables and dynamic routing gateway route distributions. So using these two entities, we can define routing policies. And by routing policies, I mean If this is your DRG and this is your attachment, let's say VCN attachment, if a traffic enters into DRG, what happens to that particular traffic? That is governed by these two entities. Now, there are two types of routes that we can have inside a dynamic routing gateway. The first is a static route. Static route is something that you create manually. And secondly, there is something called dynamic route. And dynamic route is imported automatically into the dynamic routing gateway route tables using your import route distributions. In the previous lesson, I talked about import route distributions, how they are related to the DRG route tables. So we have two types of routes, static as well as dynamic. The thing with dynamic routing gateway is each dynamic routing gateway attachment, for example, this is VCN, this is going to have an associated route table. Let's say this is remote peering connection. This is going to have an associated route table. And what is the purpose of these route tables? The purpose is to route packets entering DRG to the next hop. So if this is the DRG, let's say this is an attachment, VCN attachment. So let's say the packet enters into the DRG using this VCN attachment. Now, how is the packet going to route? So what is going to be the next hop for this packet? That is going to be decided by using the DRG route table, which is assigned to this particular attachment. You remember I mentioned that by default, there are two DRG route tables which are automatically created. So one for the VCN attachment and one for all other attachment types. Also keep in mind that you can have a dedicated route table for each attachment. So this is also possible. What is also possible is you can have the same route table for multiple DRG attachments. And in the default case, there are two route tables, one for VCN attachments and the other one for all other attachments. Because we have also discussed VCN route table in one of our previous lessons, therefore it becomes very important for me to help you understand the difference between a VCN route table and a DRG route table. So whenever you configure a VCN attachment, let's say this is a VCN and this is an attachment. Primarily, there are two route tables, one VCN route table and one DRG route table. So this DRG route table, the purpose of this DRG route table is to route packets entering the dynamic routing gateway. And the purpose of this VCN route table is to route packets entering VCN. And how can the packets enter VCN? Through the attachment. So inside the VCN, how the routing happens, that is decided by the VCN route table. And whenever the packets are entering the dynamic routing gateway through the attachment, what is going to be the next hop? That is going to be decided by this dynamic routing gateway route table. So two types of route tables. All right, this marks the end of part 2 of dynamic routing gateway lesson. I hope you liked this whiteboarding. Thanks for your time. Welcome to this part 3 of the discussion on dynamic routing gateway. Let's get started. In this lesson, I am specifically going to talk about dynamic route import and export. Welcome to this part 3 of the discussion on dynamic routing gateway. Let's get started. In this lesson, I am specifically going to talk about dynamic route import and export distribution. First, I will talk about import distribution. On one side, there is dynamic routing gateway route table. On the other side, let's say there is this DRG and there are these different types of attachments. This dynamic route import distribution specifies how the route advertisements that are coming in through these attachments, they are inserted into dynamic routing gateway route table. How are they going to be inserted? That is what is controlled by this import distribution. And this distribution is nothing but there are some list of statements. They contain a match criteria. If you create a statement with the match criteria all traffic, then all the route advertisements that are coming in through the attachments are going to be inserted into the respective dynamic routing gateway route table. And I also mentioned that in case of dynamic routing gateway route table, we can have two types of routes. The first one is static, and then we have dynamic. Static is manual, and this dynamic is basically inserted using this import distribution. Now, how does the flow look like? So first of all, we write the statement with the match criteria. Then let's say it matches on an attachment. So what it basically means is that the routes, whichever routes are associated with that particular object that is attached to the DRG, that gets dynamically imported into the dynamic routing gateway route table, which is assigned to the distribution. In the first part of DRG discussion, we have discussed that for every dynamic routing gateway route table, there is a dynamic route import distribution which is assigned. And remember, when you are writing statements in this dynamic route import distribution, the lowest number, basically you have to give a number to the statement, and the lowest number is going to have the highest priority. Now let's also talk about the dynamic route export distribution. So this is the reverse of import distribution. Now this specifies how the routes are going to be advertised to the attachments from the respective route tables or from the assigned route tables. So how the routes are advertised to attachments from their assigned route tables. That is what is your dynamic route export distribution. Now here also there are some exceptions. For example, let's say this is your DRG. There is an IPsec tunnel or virtual circuit attachment. So this is the first one. And then there is another, the second one, IPsec tunnel or virtual circuit attachment. So the routes that are imported from an IPsec tunnel, they will never be exposed or they will never be exported to other IPsec tunnel or virtual circuit attachments. So that is not possible. And by default, there is one route export distribution when you create a dynamic routing gateway. There is also a concept of ECMP, which means equal cost multipath routing. First of all, this is by default, it is off, and this is enabled on a route table. So whenever you create a route table for dynamic routing gateway, you can enable ECMP. And what this ECMP does
is that it is going to facilitate load balancing of network traffic. Now, load balancing of network traffic over multiple fast connect virtual circuits or multiple IPsec tunnels using border gateway protocol. All right, so this is what is your equal cost multipath routing. Now, the final thing that I am going to discuss is with respect to route conflicts. Remember that static routes always have the higher preference than dynamic routes. So that is your rule number 1. Secondly, if there is conflict between the dynamic routes, that is going to be resolved by the route's autonomous system path. And for VCN and static routes, the AS path is normally empty. And for IPsec tunnel and virtual circuit, the AS path will be populated. So in terms of priority, first it is going to be static. After that, VCN, then virtual circuit. After that, we have IPsec tunnel. And finally, there is remote peering connection. Now, this is the priority in case there are route conflicts. Now, let's look at some of the examples to help you understand this concept of DRG routing. Let's suppose this is DRG and there are two attachments. The first one is VCN attachment. The second one is remote peering connection attachment. Now, when you create a DRG, there will be two route tables. One is the auto-generated route table for VCN attachments. So this is going to be the route table. And secondly, it is going to be for all other attachments. In this case, it is going to be the RPC. When we have not attached this VCN and RPC, initially the DRG will have two routing tables. There will be no static routes. There will be no dynamic routes. So even in this case, there is no static and there is going to be no dynamic routes. So this side is before attachment. How does the route table look like? And this side is after attaching the VCN and RPC. How it is going to look like? Even after attaching, if you don't add any rules manually, there will still be no static rule. But in case of dynamic, it will have entries for VCN and entries for remote peering connection. In case of other attachments, after attaching RPC to DRG, if you don't add any static routes, there will be no static routes. And in case of dynamic, there will be only one for VCN. And technically this VCN, let's say this VCN has two subnets. So there will be two entries. So what does it mean? By default, by design, the VCN route table will learn all the routes from all attachment types. But the dynamic routing gateway route table for other attachments, that is going to learn only the VCN routes. So that is the default behavior. And yes, you have the option to create your own import route distribution and create your own DRG route tables for each attachment type. But I talked about the default behavior. So this marks the end of the third part of this dynamic routing gateway. Thanks for your time.
Welcome to this lesson on Dynamic Routing Gateway. It's time to revisit the deck. Let's get started. What is a dynamic routing gateway? It's a virtual router which facilitates communication between on-premises network and virtual cloud networks. And there's a concept of attachment. So in DRG, basically we can have different types of attachments, and every attachment is going to have its own associated route table. And we have discussed in the whiteboarding that by default, whenever you create a dynamic routing gateway, two route tables are created. We also talked about the concept of static route and dynamic routes via import route distributions. So inside a dynamic routing gateway route table, you can have both static routes and dynamic routes. And you can attach which type of resources to a dynamic routing gateway: VCNs or virtual cloud networks, remote peering connections, site-to-site VPN IPsec tunnels, fast connect virtual circuits. And apart from this, you can also have cross-tenancy attachments and loopback attachments. So this slide talks about the different types of attachments that we can have with dynamic routing gateway. I already talked about it: VCN, remote peering connection, IPsec tunnel attachments, virtual circuit attachments, and loopback attachments. So in this diagram, you can see that the DRG is in the middle. There are VCN attachments, RPC attachments, and this is basically depicting the different types of DRG attachments. So let's also talk about the DRG route tables and route distributions. Whenever you create a DRG, two default route tables are going to be created: one for the VCN attachments and one for all other attachments. Although there are two default route tables created, you can create a DRG route table and then you can associate it with the network resource that is attached to your dynamic routing gateway. So that option is always there. And we also talked about equal cost multipath routing in the whiteboarding. So what are the typical use cases of dynamic routing gateway? The first is simplified configuration. We know that a single DRG can have multiple VCNs attached to it. And the best part is these VCNs can belong to the same tenancy or a different tenancy. So in case you want to peer two different virtual cloud networks in the same region, you don't need to set up multiple local peering gateways. Just having one dynamic routing gateway will solve this purpose, and hence simplified configuration. High availability. Using DRG, you can use OCI Fast Connect in one region to communicate with resources in a VCN in another region. Increased scale. A single DRG can have up to 300 local VCNs attached to it. And then using DRG, you can also design transit routing scenarios. So basically, you can create a hub and a spoke architecture. Complex routing. The DRG allows you to specify a unique route table for each attached network. Now, communication between the DRG attachments, that includes virtual cloud networks, is controlled by these routing tables and the associated import policies. So using DRG, we can also support topologies like hub and spoke, which also allows you to use network virtual appliance in a hub VCN to filter or inspect the traffic between your on-premises network and a spoke VCN. So DRG caters to all those complex routing requirements. So this is a quick visualization of how the DRG routing engine works. So first step is when the packet arrives into DRG from the different types of attachments. Then a route lookup is performed on the route table that is associated with the ingress attachment. Now, if it's a VCN, then the lookup is going to be performed in the route table associated with the VCN attachment. Ultimately, the packet is going to be forwarded by the DRG routing.